Thank you, Tejas. All right, good afternoon, witches and wizards. I'm gonna bring you, and together we'll take a walk in the dark forest. This is actually a glimpse of our future together in this presentation, but it's also a promise that after this talk, you will be able to transform code like that. Just thinking about what you want to do, hit a shortcut, and get it done. So if it's looking like we're transforming code magically very fast, you're going to know how to do that. My name is Nicolas Carlo. Thank you very much, Tejas, for the introduction. And today, for the next 30 minutes, I will be your teacher for refactoring against the dark ages. I don't know what happened to the previous one, but I am a freelance web developer. I'm also a community organizer in Montreal, Canada, where I live. So for that, before we continue, I would like a thunder of applause for the organizers and the volunteers making JSHeroes magical today, please. Don't forget at the end of the conference to give them a piece of cloth so they can be free again. I've seen some merch around there. Okay, yes, I've been working with legacy code for a while, and that's my fault. That's because I kind of like it. I like fixing stuff so much that for JavaScript, I indeed developed my own VS Code extension because I was not satisfied with what the tool could do. I also wrote a book to help people work with legacy code bases in general, and we had great presentations before on technical debt, migration, all that. If you want to talk about this, I will be happy to. I want to try something and make it interactive. So if you want to play, you don't have to. Use your magic phone, scan this code, or you can go on slido.com and use this code, and put your name in the goblet of fire. We're going to have a quiz. So throughout the presentation, I will have 4 questions for you. Each question, there is only one correct answer. Nice. People are coming in. So one correct answer. And to make that interesting, you know what? There will be a leaderboard at the end. So the person who is the most correct and the fastest will get a free copy of my book. All right. Oh, we're going to hit capacity. I was not expecting so many people. OK, there is a max capacity of 100. Oh, no, we're going over. Nice. Well, I mean, it's Slido, what they said. All right, we're going to get started. So I'm going to talk a lot about refactoring in this presentation. So we better know what that means. So the first question is, and you can look at your phone, what's the definition of refactoring? Haha. OK, so let's see the results. You're good. You're good. Changing the structure, preserving the behavior, bugs included. This is the correct answer. And for the moment, Josh Max Waggins is the first. But it's very close. Like, pay attention. That was only the first question. There will be more. So yes, this definition comes from Martin Fowler, great wizard, it was mentioned before. The book Refactoring, it's a great book. By the way, the second edition was in JavaScript. It's a cookbook, really, of recipes of different 65 refactoring moves you can do. So refactoring is changing how the code is written, but you keep it working like it was working before. If there was a bug before, you refactor, there is a bug after. Now, you refactor to make it easier to change the code, like to fix the bug or to implement the feature. And how do you know you have successfully refactored? You test before and after to see if the behavior has changed. You can do it manually. If you don't, someone will do it for you on production. I do not recommend that. And that's why we love automated tests, because the computer can do that work faster than we can. What if the code is not tested? Like, we're talking about Beast, and this is, in my experience, what most people are dealing with. Well, if your code has no test, this is Michael Feather's definition of legacy code, another great book, by the way. It's not just no test. It's no test, poor documentation, the person who wrote that code is gone, or it was you, but a year ago and you don't remember what this is about. So working with legacy code is special because you wish you would have automated test. But when you try to write the test before you refactor because you want to do things right, you realize it is hard to do. It is hard to write tests on existing code. And so you kind of need to refactor the code first so you can at least write some tests. But you don't have the test to get your back. So what do? Well, if you don't have tests to cover your back, most people, they just try to hope for the best and not break things. In general, we are very conservative. We try not to touch the code as much as possible. The thing is, there are better ways. First of all, we could be following recipes from Martin Fowler. So if you've read the book and you learn the recipes, you have tools to get working with that. But I don't expect all of you to read the book, and I'm going to come with something a bit better. We have automated some of them. And you may not be aware of it, or probably not using it, but we're going to lean a lot on automated tests. It's not as safe as with automated refactoring. It's not as safe as with automated tests, but it's safer than just touching the code. So that's our plan. First of all, I want to talk about 3 core refactorings. These moves are essential. Like any larger refactoring will actually use some of these. Which leads us to our first question. Who is using VS Code here? That's why I assumed. Okay, sorry if you're not, but the second question of the quiz is, what is the shortcut to rename something in VS Code? Most of you are correct. I'm really proud. Actually, I'm impressed. Shift F6, I'm sorry I tricked you. This is IntelliJ. For the few folks who answered the Konami code, I love your vibe. Keep it up. Joshipo, you're still the first one, but Philip is just behind your neck, so be careful. We are halfway. Okay, yes. Renaming things in VS Code, it's F2. It's very powerful because you can put your cursor wherever on the variable, the function name, the method, whatever. You hit F2, and now you have an input asking you, what's the new name? You type the new name, you hit Enter, and it resolves for you all of the references everywhere. You don't have to do it manually. It is faster and also safer. So if there is one shortcut you should remember from that presentation is use VS Code F2 or Shift F6 if you're using IntelliJ. We're going to see more. But for the rest of the presentation, what I'm going to use is provided by Abracadabra if you're using VS Code. If you're using WebStorm or JetBrains, I've heard there are some JetBrains licenses, you have probably the best tool for automated refactorings. The when chooses the wizard, so maybe you don't have one of these and you have something else. It doesn't really matter, but if the 3 core refactorings cannot be made automatically by your tool, I would probably reconsider. So, very important, extracting things. We extract things not just to remove duplication, but to introduce concepts in the code base. So for example, this condition here, I can read JavaScript. Yeah, I can read that code, that's fine. But what does it mean? What's the intention? Well, the thing is, I could select partially the thing, hit a shortcut, and bam, the variable is extracted for me, and now I can just name it, and I'm done. Sorry. So that works with variables. I can also do that with functions. Sometimes a variable is not enough. The good part is it forces you to think more about what you're doing. Give it a name means that you need to understand what you're doing. And it's hard to get right the first time. It's okay. It's a process. You can do it progressively. Sometimes the abstractions are not good anymore. Like sometimes they're good, and then eventually they're in your way, or you need to change the code in another direction. So you want to undo this. Undo is in line. having a shortcut to inline things is also very useful. So you could do that manually, but that will be long, and usually people just don't. I can go on the variable, hit the shortcut, and all the references are inline. That's the 3 core refactorings we're going to use. Next up, I'm going to see 3 more. These ones are more situational. Like, we don't use them all of the time, but they're going to be handy in our case. The first one is splitting the declaration and the initialization. So, say this variable, it's a const, it's assigned, it cannot be reassigned. Okay. Sometimes you may want to reassign it or to separate these 2 faces. You could do that manually, declare a let const above and remove the const. That's what you will actually change. But here we're going to get ourselves trained into using shortcuts. For all of the 40 refactorings that are not core, you can just do Alt-Enter. So you put your cursor where you want, you do Alt-Enter, and it will suggest you anything you can do automatically for you. You select, you do Enter, and you let the tool do the transformation for you. Why would we split these 2 faces? Well, in general, because we need to move around the initialization. And how you do that, you use slide statements. Now, you're probably familiar already with moving lines down and up. Maybe you're already using the shortcut in VS Code for that. Just this one refactoring is riskier than the others. For example, at this moment, the code is broken. The variable cannot be accessed anymore because it's within the if block statement. It's going to be brief, but we also like to be mindful of this and keep the code in a working state at all time. With Abracadabra, I actually have another shortcut to just slide statements, so it will actually swap the whole if statement with whatever you're moving down. Final refactoring, moving statement out of if else. So this one is also very situational. Imagine you have an if and an else, and the last statement are exactly the same. Well, you can refactor that code in general by moving the statement out under it and clean up the code. You can do that, but you will do Alt-Enter, Enter, let the tool do the work for you. Because sometimes it's easy like this. It's a toy example. Sometimes it's very nested. Okay, we have our 6 spells, and get ready for the next question. I said earlier that legacy code, you realize it's hard to test, to write tests for it. The question is, why is that? Yes, I don't want to trick you. When there is all of these in only 10 seconds, that's the correct answer. So, wow, you're good, but the competition is hard. There will be one final question. Keep it up. All right, what are all of these? I listed HTTP call, third-party services. I could say time, randomness, databases, anything that is outside of your code. These I will be calling I/O. I/O are the things that are outside of your code that you need to use to do anything interesting. So think about the API you need to call, like I need to call OpenAI to have their LLM compute stuff and give me an answer. I want to delegate payment to Stripe API. I want to store things in a database and I want to retrieve things from it. That's what I'm going to use, but I'm going to also use it to expose what I'm doing. So for example, you may have an HTTP endpoints or GraphQL endpoints, or both. If you're doing front end, you will be using the browser API, or you'll be using a framework that is doing it for you. All of these are interesting, but they usually are where the problems start when it comes to testing. Not saying that you should not test it, you should. But there is another part of your code that should be at the heart of your software. The very reason you're writing this software in the first place is the domain, the business code, the business logic. all the if, else, while, for, computations, moving from a data structure to another, all of these rules that you're talking with business people to get implemented, to have the software do it for you. This is the domain code. And the problem is, in general, and especially when it comes to testing, people don't really talk about software architecture, but the two go together. And it's not a presentation on software architecture, but the problem is I/O and domain, they got intertwined. We don't think about software in terms of I/O and domain, and so we just write code that couples these two. It becomes actually really interesting when we start thinking about these two phases and we separate them. So that's what we're going to do. One last thing. Because separating the I/O from the domain is something that is recurring when working with legacy code, I like to see where is the I/O. And the problem is when you have, imagine this is messier, it's hard to tell. There is a lot of things going on. So I have another thing that is not a refactoring, but you can highlight persistingly all of the references to a variable. We're going to use that to cast Lumos on the code base. And you're going to see how things are intertwined together. OK, we have everything we need. Now it's going to be live coding. So we're going to step together. Don't worry, you're with me. We're going to do a refactoring called distill and extract. And it's a really powerful refactoring, but it cannot be automated because it depends on what you're dealing with. But, and here is the trick, we're going to only use the automated refactoring moves I've seen. I am not allowed to actually type code. So remember, the goal is we have I/O, we have domain, they are intertwined. We want to first distill the two phases, like a potion, to have a large chunk of domain that we can extract. That's the spirit. Yeah. All right. So let's meet our legacy beast. Honestly, it's not too bad. It's not pretty. But I know you have worse at work. But it's good enough to illustrate the point. So this is an Express application. Like there is a get endpoint on /prices. We have a database, SQL queries going on. And then we do some calculations for the price of the ticket. And eventually, we return a response with the cost. And interestingly enough, that's everything we do. All right. So how do we test that? Like, say I want to fix a bug or change the logic, and the logic is, it's not really pretty. I may make a mistake, so I would like to write some test. What's going to make it hard to test? Well, I mean, it is testable. I do have tests. But what's going to make it hard to test is things outside of our control. So we need to run the server. We need a database running with the data inside. I mean, it's doable, but looking at our logic, there are at least a dozen tests to verify all the possible scenarios. And actually, it went faster this time, but 8 seconds for 12 tests. It is slow. It does not scale. You cannot have thousands of tests like that. What we're going to aim for is for our test to take 1, 2, 3 milliseconds. Under 10 milliseconds, it's a good switch. You want to have most of your tests super fast, super reliable. Now, these tests are helpful because it's testing that everything connects together. But I need one of that. I don't need 12. I am having 12 tests because of all of these rules here. So let's do the separation. First of all, what does not belong to us? Oh, yeah, we could also extract the whole controller and try to test it, but that's the problem, especially with TypeScript. This request here and response, they're coming from Express. Do not mock what you don't own. Like these interfaces, they don't belong to your code. You're consuming them. Don't try to mimic them. You will just suffer pain over time. Anything with a weight is suspicious. In this case, yes, we're using a library, whatever it is, and whatever version it is, because API upgrades with breaking changes. So the connection thing is also something I don't really want to mock. Okay, and now that as I'm scrolling down, I can see it's sprinkled everywhere, the request, the response, all of that. So let's untangle that, and again, only using automated refactorings. So let's start with the request. We are currently using request query, which is fine because request query is just an object, so that's easy to simulate. So what I'm gonna do is move the references up. How I'm gonna do that? Extract variable. So hit the shortcut, then it's asking me all of them or just this one? All of them. And then style preference, yeah, destructure it. Just like that, we have removed all references from request. It's still here, it's still the query, but now I don't only have to provide a query, not the whole request interface. Let's go with this one. This one is fetching data from the database, holidays apparently, only in this branch though. Now, sometimes it may be okay to pull it up and to always fetch and to give the result to the function, but let's preserve this behavior. We don't always make that query. So I cannot extract a variable. I need to introduce an indirection. To do so, I'm gonna extract it in a function. And that function forces me to also give it a name. It's interesting. So what this is doing, really, it's fetching the holidays. I don't really care exactly how it's stored. What I want is to get a list of holidays asynchronously, which is going to be more convenient to fake in the test. OK, we are left with rest.json. So to respond to the client, we could do something similar, have a send response function and call it a day. In this case, by a happy accident, it turns out we're calling rest.json with the same structure everywhere in all the branches. So it would be nice to actually move these out, like I mentioned before. So I do Alt-Enter, and it's not here, because it cannot be done at this point. Why? Well, because they are not exactly the same. So let's make them look the same. How to do so? Well, I'm going to extract what differs, what is different. In this case, the value of cost. So I do extract variable here, I do extract variable here, and now they look the same. So now I can do that. If I try to do that, TypeScript will tell me you have a problem here because the variable here is not available anymore. So it's pretty much like Philip said before. It's not sound. Be careful when you do this refactoring. Sometimes it doesn't work. And hopefully tools like linter and TypeScript, if you don't have test, at least you have some safety net here. So let's undo that. Let's also go through all of them to make them look the same. So I'm going to just extract variables everywhere we have that, like here, like here. Oh, another issue. Yeah, cost is already written here. So I'm going to undo that. Whenever the code is broken, I undo, because I want to get back to a state where it's working before trying to fix it. I undo, get back to a safe state. And then what can I do? Well, you know, this abstraction, this variable is not useful anymore. I'm going to inline it very quickly so I can extract it again. Oh, and same stuff here. And same stuff here. OK, are we done? Almost. Right. So it would be nice if we declare the cost variable before all of this and make it available for everyone to override. So we can pull out the response.json. Well, good news, this is one of the moves we have seen. We can split the declaration and the initialization, and then slide statement. Risky move. In this case, when you create new stuff, it's generally safe. So here we have made things messier. Remember what Sophie said before, when you're refactoring stuff, in the process, things get more dirty, but if you know where you're going and you trust the process and you go to the end, it will clean things up. OK, now that we have that, I am going to just go over all of these using VS Code multi-selection and stop shadowing the variable. So I don't redeclare a cost variable. I just use the one that is available. And now we should be able to do that. and again, and again. Oh, not here, because yeah, we need to unwrap this. So we need to start from the most. Yeah, that's how it looks when you have your target in mind and you get there, you just go through it. And the code kept working at all times. Now we are left with this big chunk here. This is our domain logic. We're going to extract it at the top level, and VS Code is dealing with, I'm going to give you the variables that you need. And now we need to give it a name. So in this case, apparently it's calculating the cost. So that's the name I'm going to give it. And what do we have left? Well, the I/O stuff. So I can clean things up. This extraction not useful anymore. I can inline it. Here I may want to make the connections before. This result, probably badly named. It's certainly the base cost. If you don't know yet, you can rename later. So there you are. Actually, let me go to... Once we have that, you have extracted away all of this logic. It's still messy. I didn't clean up. There is much more refactor I need to do. But this is much more trivial to test, because now I'm not depending on Express or the library to do queries or anything that could be annoying in your way. That you cannot call in test. And now we can write our 12 test in isolation. And look, the same test, same logic, they take 6 milliseconds for all of them, which means I can use them in watch mode. So now I'm going to start refactoring the code, and I do have automated test. And if I make a mistake, like let's make a deliberate one, I have instant feedback on that. Now I can do more ambitious refactorings because I have fast and reliable test. But to get there, I only leaned on automated refactorings to make changes safer. All right. Here comes the final question. And this is a matter of, did you pay attention? Ready? Okay. Which refactoring was the riskiest? Look at that, amazing. Yes, this is the correct answer. So congratulations, and congratulations to Philippe. Congrats. I told you everything can change at the last minute. All right. Be safe out there. This is a port key. It will give you two things. First of all, a feedback form. That's for me. What can I do to improve this presentation? Second, a bunch of goodies. So if you want the slides, the animations, further links, and recommendations, you will have all of them at this URL. And that being said, legacy code can be scary, but you have the magic in you. You just need to use it. So take care.